Have you ever read the ISO 26262 and thought to yourself, the standard is very vague? If the answer is yes, in this video, I'm going to try to break down what is the ISO 26262, what are the different chapters in ISO 26262, and what is the content of each chapter. ISO 26262 is the standard for functional safety for automotive systems. It was originally released in 2011. There was a revision published in 2018, and one more is expected very soon. ISO 26262 ensures that EE systems in vehicles, which are cars, trucks, and motorcycles, are safe even in the presence of faults. Now, ISO 26262 talks only about EE systems, which is electronic components. It does not talk about completely purely mechanical and hydraulic systems. So it's only confined to EE systems. ISO 26262 has a risk based approach wherein we use certain techniques to identify risks, also known as ASILs, Automotive Safety Integrity Level, to determine whether a fault is high risk or low risk. And the entire specification, it talks about how to reduce the risk as much as possible. ISO 26262 is designed for the entire product lifecycle, all the way from a concept phase to design to production, and then all the way manufacturing and even up to decommissioning. Just like any other safety standard, the ISO 26262 consists of three aspects. There is an organization aspect, which is what should an organization do to ensure safety of the product that it's building. There is a technical aspect, which is how do I technically make this product safe? How do I make the software safe, the hardware safe, the system safe, or even the manufacturing safe? Then there is the process aspect, which is when I'm doing a safety activity, how do I ensure that the right process is followed so that there is no non compliance? The latest edition, which is a 2018 edition, it consists of 12 chapters. Each chapter covers certain areas. Part 1 or chapter 1, it it covers vocabulary which defines several terms that is constantly and repeatedly used in ISO 26262. Part 2 is also called as management of functional safety. It covers a lot of organizational and management related aspects. In detail, it also covers project relevant management aspects and project independent aspects. Project dependent aspects include what is the plan, what is the to execute functional safety, how the safety case is created. Project independent activities include things like how to establish safety culture in the organization, what is the training plan for the entire company. Part 3 talks about concept phase. This is where the technical work begins. It starts with creating an item definition, then a HARA to create safety goals, and then a functional safety concept. If at all you're ever stuck as to as to where you need to start functional safety, it's here at concept phase. Start with the item definition. Part 4 is the product development at the system level. It talks about how technically the product can be made safe. What are the sensor suite that needs to be used? What are the safety mechanisms and where are they going to be implemented? Part 5 talks about hardware development. And by hardware, here it refers to microcontrollers, EE components like motors, actuators, solenoids, valves, etc. How can hardware safety be ensured? Hardware safety includes things like hardware design, hardware safety analysis like FMEA, FMEDA, maybe dependent failure analysis, and also calculation of hardware metrics, PMHF, SPFM, LFM, which we'll talk about later on. Part 6 is the product development at the software level. It is how should I develop safe software? What kind of safety analysis do I do around it? What kind of testing should I perform? Once hardware software is developed and they're integrated together, we go into the production operations service and decommissioning phase, which is part 7. Part 7 talks about what should I do to take a product into production, what can go wrong during production, and how to mitigate it. Similarly, what can go wrong during operation, service, and decommissioning, and how do I mitigate? Part 8 talks about supporting processes. This is applicable throughout the life cycle of product development. How do I store information regarding the project? How do I manage changes in the project? What are the tools that I'm going to use to execute the project? And how to qualify and classify and qualify the tools. There is a big topic around tool qualification. Part 9 is ASIL oriented and safety analysis. It provides some tips and techniques into how safety analysis like FMEA and FTA can be performed. It also talks about how FMEA and FTA can be combined. Part 10, again, more supporting on the technical processes. It provides examples of how HARA can be performed, how hardware metrics, PMHF, SPFM, LFM can be calculated. Part 11, which was added in the second edition of the ISO 26262, talks about uh, semiconductor components and how safety of semiconductor components can be achieved. Part 12 is an adaptation of motorcycles. It talks about how ISO 26262 can be applied to motorcycles. It introduced the concept of MSIL, which is the equivalent of an ASIL for a motorcycle. If you are a safety manager who's trying to understand what needs to be done from safety, it is very important that the safety manager understands all the work products and processes in all parts of the ISO 26262. If you're a safety engineer who's working at a system level, it's important that you understand part 3, part 4, part 7 of the ISO 26262. If you're a hardware engineer, part 5 is a very, very important aspect. Similarly, part 6 is very important for software engineers. Hardware engineers, depending on what component they are working on, may also be interested in part 11, which talks about hardware of semiconductors. Overall, to be a good safety engineer, it's important that one understands what every chapter of the ISO 26262 entails. This helps in making recommendations towards how safety can be achieved in the product.